Stars are huge celestial bodies made mostly of hydrogen and helium that produce light and heat from the churning nuclear forges inside their cores. Aside from our Sun, the dots of light we see in the sky are all light years from Earth. Giant gas clouds. A star originates from a large cloud of gas. The temperature in the cloud is low enough for the synthesis of molecules. The Orion system is an example of a star in this stage of life. Protostars. When the gas particles in the molecular cloud run into each other, heat energy is produced. This results in the formation of a warm clump of molecules referred to as the protostar. The creation of protostars can be seen through infrared vision, as the protostars are warmer than other materials in the molecular cloud. Several protostars can be formed in one cloud depending on its size. A protostar looks like a star, but its core is not yet hot enough for fusion to take place. The brightness we observe comes from the heating of the protostars as it contrasts. They are very difficult to be seen because they are surrounded by dust and gas which block the light they emit. Planetary pace. Planetary stars are so young and low-mass stars. These stars are among the first young ones to be identified because the earlier stages still embedded in their birth clouds were blocked from optical observations by the dust. So they now become visible at optical wavelengths. Planetary stars shows both periodic and random fluctuations in their brightnesses. Main sequence stars. In this process, the protons of hydrogen are converted into atoms of helium. This reaction is exothermic. It gives more heat than it requires, and so core of main sequence star release a tremendous amounts of energy. During this stage of our universe, the majority of all stars in our galaxy and the universe are main sequence stars, including our Sun. These types of stars can vary in size, mass, and brightness. Red giants. A red giant is a star that has exhausted the supply of hydrogen in its core and has begun thermonuclear fusion of hydrogen in a shell surrounding the core. Aldebaran and Neva are well-known red giants. The red giant phase of a star will only last for a few 100 million years before it runs out of fuel completely and becomes white dwarf. The fusion of heavier elements. Helium molecules fuse at the core as the star expands. The energy of this reaction prevents the core from collapsing. The core shrinks and begins fusing carbon once the helium fusion ends. This process repeats until iron appears at the core. The iron fusion reaction absorbs energy which causes the core to collapse. This implosion transforms massive stars into a supernova, while smaller stars like the Sun contract into white dwarfs. Supernovae and planetary nebulae. A planetary nebula is born when a low-mass star dies, while the supernova is the death of a massive star. When massive stars are dyed, it is the gateway to the formation of a stellar black hole.